Hi there. In this tutorial, I'd like to take another look at Guess the Number. This is a two-player game between a computer and a human. The computer selects a secret number, and the human has to guess the number. It's a pretty good game. The trouble is that it makes the human do a lot of mental arithmetic. So why don't we turn the tables? In other words, let's make a game in which the human gets to think of a secret number, and it's the computer's role to guess the number. That is the game I'm going to implement right now. I'm importing the simple GUI module, which doesn't come with Python itself, but is built into CodeSculptor. In the frame, I'm setting the width of the canvas to 0 because I'm not going to use it. The whole frame is going to be the size of the control area, 250 by 250 pixels. I'm making a label and an empty input field where the human player can enter the upper limit for the game. The start method of frame pops up the window with the frame and the elements I've added to it. For now, just a label and an input field. When the user enters something in the input field, handle upper limit gets called. I take the string in the input field, get its integer value, and display it. That's enough to get started on the program. Let me run it and see if it does what I expect it to do. I type in an upper limit, then hit the enter key. There, it's displayed in the text output. Try another value. It works. Good. Instead of simply printing the upper limit, I want to start a game with it. I'll put that code into a separate function called newGame. The variable upper limit was local to this function, but I'll want to access it from other functions, so I'm making it global. The advantage of putting the code that starts the game into a separate function is that I can define it once and then call it from various parts of the program, not just from handle upper limit. Again, I'm displaying the upper limit, and now I'm asking the user to think of a secret number. I've made some changes to the program structure, so let me see if it still works. I'm entering various values for the upper limit. It's displayed correctly. Good. Next, the program should start guessing the secret number. How are we going to make a guess? Well, we already have an idea of the range in which the secret number falls. For example, if the upper limit is 10, we know that the secret number is less than 10 and not less than 0. In this diagram, I'm treating the upper limit in the same way as Python does, and I'm using conventional mathematical symbols. The upper limit is exclusive, meaning that it is not in the range, so I'm denoting it with a parenthesis. The lower limit of 0, however, is inclusive. It is in the range, and I'm denoting it with a square bracket. Now, a convenient way to make our guess is to choose a number that falls midway in this range. In other words, we take the average of the lower limit and upper limit. Here, the average of 0 and 9 is 4.5. We have to pick an integer value, either 4 or 5. It's a good idea for us to round down because that's what Python does automatically with integer division. The range of possible values for the secret number is going to change in response to user feedback. The global variables low and high will let the program keep track of the low end and high end of this range. Initially, according to the definition of the game, the low end is 0 and the high end is the upper limit. When we make a guess, we take the current values of low and high, whatever they might be, and compute the average. That's the sum divided by 2. Let's show the user everything we know. We'll print out low and high, which define the range of possible values for the secret number. Then we display the value that we've computed within this range. It's a value in the middle, and that's our guess. Let's see if it works. If the upper limit is 100, the first guess should be 50. Let's consider what happens when the human player responds to the guess. If the guess happens to be correct, we're done. Otherwise, the human tells the program how to narrow the range. If the secret number is lower than the guess, we have to turn our attention to the left part. The number is smaller than our guess. If the secret number is higher, we turn to the right part. Number is bigger than the guess. In both of these cases, the new range will leave out the guess itself because it was incorrect. If we're going to the left, the upper limit will land exactly on the guess. Remember, the upper limit is exclusive. But if we're going to the right, the lower limit, which is inclusive, will now be equal to the number that is 1 greater than the guess. Before we can process the human's response, we have to make some buttons that the human can use to give a response to the guess. First, there's an empty label to make some space between the input field and the next label. Below it, we'll put the commands that make the 3 buttons. It makes sense to put the buttons in visual order. Higher at the top, correct in the middle, lower at the bottom. We're giving each button its own event handler named after the button. The event handler for a button gets called when the user clicks on the button. Unlike the event handler for an input field, an event handler activated by a button doesn't receive an argument. Now that the commands for the buttons are done, let's write the handler for the higher button. Here it is with the empty argument list. As we said before, the thing to do if the secret number is higher is to adjust the low end of the range so that it's one greater than the guess. Once that's done, we're ready to make the next guess. Now for the lower button handler. Here, we want to adjust the high end of the range. We're setting it to the guess because we know that the secret number must be less than that. Again, the next step is to make another guess. Finally, for the correct button handler, what do? Let's simply end the game with a congratulatory message. Then let's do some testing. I'm playing with an upper limit of 10, and my secret number is 4. I answer the questions honestly, and the computer narrows the range until it knows that the answer is 4. Let me play again with a secret number of 3. Once again, it seems that everything is going fine, except if we look at the question where low is 3 and high is 5, at this point the secret number is either 3 or 4. The program should know that if it's not 4, it must be 3, and there's no need to ask one more question. How exactly can we tell if there's no need to make a guess? Well, it depends on the size of the range. If the range includes at least 2 numbers, we can't be sure which one is the secret number. But if the range is so small that there's only one number in it, we know that has to be the secret number. This is going to be the case when the upper limit is exactly 1 greater than the lower limit. That's the condition we have to check for. Here's the implementation. In the makeGuess function, if flow plus 1 is equal to high, we immediately end the game and return, which means that we leave the function without executing the rest of it. I'm writing a new function to end the game because there are 2 different places in the code where the game ends. One is when the human player tells us that the guess is correct, and the other is when the program deduces that the secret answer can only be one value. We print out the answer and thank the player. We've already called the game over function from makeGuess when the range shrinks to 1 value. Now let's call it in response to the human clicking the correct button. Let's run the program again with the secret number of 3. This time there should be 1 fewer guess because the program recognizes that the range has shrunk to 1 value. There we go. We'll test again with the secret number 4 to make sure that the program still works in the case where the human says the guess is correct. The program is working fine, but it could be friendlier. Currently, it's not clear from the output how the user answered each question. You have to figure it out from the ranges. Let's output the human's response. In the event handler for the higher button, we print a message indicating that the human's response is higher. In the lower button event handler, we say that the response is lower. And we do likewise in the handler for the correct button. It's the same type of message each time. Well, hang on a minute. What if we wanted to change the message so that it started with something different? We would have to change each one of the 3 lines to keep them consistent. We can make this code easier to maintain if we factor out the part that stays the same and replace it with a function call. For the higher button, the unique part of a message is higher. We can delete everything that comes before that and instead call a function, which I'll define in a minute. For the lower button, the unique part is lower, and again, we have a function call for everything before that, and likewise for the correct button. Once we've changed these lines, we don't have to touch them again to change the first part of every output message. Instead, we only have to change 1 string in the function displayResponse. I can do it as soon as I have this line. 1 change, and all the output messages will start with "you said." Time for testing. Now, when we play the game, The output includes a clear record of the responses made by the human to the computer's guesses. Everything looks fine, but this is a short game. In a longer game, it wouldn't be obvious at the end how many guesses the computer had to make to arrive at the secret number. Let's make the program keep track of the number of guesses. We need a new global variable, which I'm calling guessCount. Initially, its value is 0. Whenever we make a new guess, we increment guessCount by 1. In other words, the new value of guessCount is the old value plus 1. This code is correct, but there's a shorter way to increment guessCount. By using the plus equal operator, we only have to put the variable name once on the left side, and on the right side of the operator, we put the amount to increment by. In the GameOver function, we can print out the number of guesses that the program made. Now let's see if it works. With an upper limit of 100, my secret number is 42. That's not a very secret number because I often use it, like many other people, but this particular program shouldn't know it beforehand. With my help, it gets to 42 in just 6 guesses. Wonderful. Now that the program is working fine, I'd like to ask a question. If I'm using this program as the human player, do I have to know the secret number? Well, not necessarily, because I can be playing on behalf of someone. A friend of mine might think of a secret number, and I could just be the go-between, relaying the computer's questions and my friend's answers back and forth. What if my friend is not a human, but another computer? What if this other computer is running a Guess the Number game? And I mean the original game, the one in the mini project, where the computer selects a secret number and the human has to guess. That situation would be perfect. One program has chosen a secret number, and the other program knows how to guess the secret number. We can let the computers talk to each other and work the whole thing out. We've taken humans out of the equation. You see, programming solves everything. Hey, thanks for watching my video, and let me know if you liked it.